Hello all, welcome to the day 74 of the daily case study series for CBSE grade 12. The question goes like this. An engineer is designing a new metro rail network in a city. Initially, two metro lines, line A and line B, each consisting of multiple stations are designed. The track for line A is represented by L1 while the track for line B is represented by L2. Based on the above information, answer the following questions. Question 1. Find whether the two metro tracks are parallel. So line 1 is x minus 2 upon 3 equal to y plus 1 upon minus 2 equal to z minus 3 upon 4. So from this we get the direction ratios of line 1 as 3, minus 2 and 4. L2 is given by x minus 1 upon 2 equal to y minus 3 upon 1 equal to z plus 2 upon minus 3. So the direction ratios of L2 is 2, 1, minus 3. For the two lines to become parallel, the ratios A1 by A2, B1 by B2, C1 by C2 should be equal. Here A1 upon A2 is 3 by 2, B1 upon B2 is minus 2 by 1 and C1 upon C2 is 4 by minus 3. Since the ratios are not equal, that is A1 by A2 is not equal to B1 by B2 is not equal to C1 by C2, the line L1 is not parallel to L2. So this is the answer for the question 1. Question 2. Solar panels are to be installed on the rooftop of the metro stations. Determine the equation of the line representing the placement of solar panels on the rooftop of line A's station, given that panels are to be positioned parallel to line A's track L1 and pass through the point 1, minus 2, minus 3. The given line is x minus 2 by 3, y plus 1 by minus 2 equal to z minus 3 by 4. The direction ratios of line 1 is 3, minus 2, 4. The direction ratios of the line parallel to L1 will also be 3, minus 2, 4. And this parallel line passes through 1, minus 2, minus 3. So equation of the required line in vector form, that is r vector is equal to a vector plus lambda times b vector. A vector is I minus 2j minus 3k plus lambda times b vector is the direction ratio 3i minus 2j plus 4k. So this is the equation of the line parallel to L1 in vector form. And in Cartesian form, it will be x minus 1 upon 3, which is equal to y minus 2 by minus 2, which is equal to z minus 3 upon 4. That is x minus 1 upon 3 equal to y plus 2 upon minus 2, which is equal to z plus 3 upon 4. Question 3, subdivision A. To connect the stations, a pedestrian pathway perpendicular to the two metro lines is to be constructed, which passes through the point 3, 2, 1. Determine the equation of the pedestrian walkway. This pathway is perpendicular to L1 and L2 and it passes through 3, 2, 1. The A vector is 3i plus 2j plus k. Now the vector equation of a line passing through the position vector A and parallel to B vector is given by R vector is equal to A vector plus lambda times B vector. The pathway is perpendicular to both L1 and L2, which indirectly implies that it is parallel to the cross product of B1 and B2. The B vector is equal to the cross product of the lines L1 and L2, that is B1 cross B2. Let's take down the ijk components of B1 and B2 from the lines L1 and L2, which gives us I times 6 minus 4 minus j times minus 9 minus 8 plus k times 3 plus 4, which is 2i plus 17j plus 7k. Now this pathway is parallel to this B vector. So equation of pathway is 3i plus 2j plus k, that is that A vector plus lambda times 2i plus 17j plus 7k. Question 3, subdivision B. Find the shortest distance between line A and line B. From L1, A1 is equal to 2i minus j plus 3k and B1 is 3i minus 2j plus 4k. From L2, A2 is I plus 3j minus 2k and B2 is 2i plus j minus 3k. Shortest distance is given by modulus of the dot product of A2 vector minus A1 vector, B1 vector cross B2 vector, divided by the magnitude of the cross product of B1 vector and B2 vector. A2 minus A1 is minus I plus 4j minus 5k dot 2i plus 17j plus 7k, divided by square root of 2 square plus 17 square plus 7 square, which is equal to minus 1 times 2 plus 4 times 17 plus minus 5 times 7 by root 342, which is equal to 31 divided by root 342 units. This is the shortest distance between line A and line B. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all with another case study question tomorrow.